Good morning, my dear students. Myself, Assistant Professor Sandeep Shah, working at Technopress TIT Group of Institute Bhopal. So we are studying heat and mass transfer subject, and today we will discuss start a new chapter, that is extended surfaces. So the table of content for discussion, subsequent discussion is introduction of extended surfaces, that is fin, classification of extended surfaces, and then we will study about the fin efficiency, fin effectiveness, and then unsteady state heat conduction, and then we will discuss about the response of thermocouple. So first we have to define what is extended surfaces meaning, and by the students, the extended surface is also known as the fins. So we know that in case of convection heat transfer, the formula for the heat transfer is given by Q equals to HA Ts minus T0. Means if heat is flowing from any surface to the fluid, then the heat transfer formula will be used this. So for any moving fluid through the surface will follow the Newton's law of cooling. And then if we have to increase the heat transfer rate, then what are the conditions which will be responsible for the increase in heat transfer rate? That is, the first one is the H, and the second one is the A, and third one is the temperature difference between solid surface and flowing fluid. So by increasing the temperature difference, we can increase the amount of heat transfer rate, and also by increasing the area or end heat transfer coefficient, we are having different so depending on this we can improve heat transfer rate. So my dear students, here the main purpose of extended surface is to improve or increase the heat transfer rate by increasing the effective surface area of the body through which the heat is flowing. Let us suppose that this is a body at a temperature TB, and to improve this, increase this heat transfer rate, we have extended the surface by some length by taking a particular sectional or cross section. So by applying the energy balance for this small element, that is delta dx, element length of dx, and area of d or AC, area of cross section is AC. So the small element heat transfer rate will be given by this formula. So by applying energy balance, we will get equation which is for a temperature distribution throughout the length of this extended surface, which is also known as fin. So we can say that here the temperature profile is exponential nature. The temperature profile of this fin or extended surface will be of exponential variation of temperature. So this is the formula of extended surfaces temperature ratio, profile of temperature, temperature distribution, which is also given by a hyperbolic function. So finally we will get the rate of heat transfer through a fin. Qf is equals to minus k area of cross section dt upon dx, and finally this formula will be used to calculate or to find out the effective heat transfer rate through a fin. Here the terms H, P, K, AC are already discussed in conduction case, conduction and convection case. So these are, we are having the four different types of heat four different types of tip condition of fin, that is the convection heat transfer, another one is adiabatic tip, and another one is at a tip at a given temperature, and next is tip or fin of having infinite length. So depending on this different category, we are having temperature different distribution profile, and also the heat transfer rate. Formula for heat transfer rate is this. Now the next term is the fin effectiveness. Fin effectiveness is just like efficiency of effectiveness is just we will define by this formula, that is effective how effective a fin can enhance the heat transfer is characterized by the fin effectiveness, the ratio of heat transferred and the heat transferred without fin. It means we are using the fin to increase the heat transfer rate. So this will be the ratio of heat transfer by using the fin and heat transfer without using the fin. So finally we will use this formula, effectiveness of fin, that is under root h kp upon hac 10 h ml. So what are the parameters on which the effectiveness of fin will depend? So finally we will after observing this formula, we can see that the effectiveness is greater than 1. However, effectiveness is greater than or equal to 2 will be considered justifiable. If effectiveness is less than 1, then we have insulator instead of a heat fin. Means if effectiveness is less than 1, it means adding the extended surfaces there is no benefit. It means the heat transfer is reducing. So to make the effectiveness more, these are the parameters. The fin material should have higher thermal conductivity, or H heat transfer coefficient should be higher. So these are the two parameters on which the effectiveness of fin will depend. And now another one is the fin efficiency. Fin efficiency is nothing but it is the ratio of actual heat transfer rate and maximum possible heat transfer rate. So by using this fin, what amount of heat, total heat amount maximum possible to actual amount is comparing with maximum possible will be given by this heat fin efficiency. So these are the formula to calculate the fin efficiency, that is 10 h ml upon ml. So next important point is unsteady state conduction heat transfer, that is transient system transient. So the process of heat transfer by convection where the temperature varies with time and with space coordinates is called unsteady or transient. All transient state systems may be broadly classified into two categories, that is non-periodic heat flow system and periodic heat flow system. So we will understand by one. So this is the this is the dimensionless parameter which will define or will use to differentiate steady and unsteady flow heat transfer rate, that is the Biot number and Fourier mass definition and significant. Let us consider an initially heated long cylinder placed in a moving stream of temperature T infinity and Ts. The convective heat transfer coefficient at the surface is H. So the heat transfer rate will be Q is equal to H at Ts minus Ts. So by using this energy must be conducted to the surface, and therefore Q is equal to minus Ka dt upon dr. This is conduction, heat conducted and heat convection. It means the Biot number basically define the term H upon Rk. HR upon K is called Biot modulus, is a dimensionless number and is the ratio of internal heat flow resistance to external heat flow resistance, and plays a fundamental role in the transient conduction problem. So if what is the significance of Biot number? Biot number if will be less than 1, then it is assumed that uniform temperature distribution across a solid. And another term is the Fourier modulus. So this is the profile of temperature of Biot number with respect to the direction and temperature. So the lumped capacity system necessary physical assumptions are this: the physical size of the body is very small, the thermal conductivity of material is very large, convective heat transfer coefficient of the surface is very small. These are the assumptions for the lumped heat capacity analysis. And the expression for calculating the lumped capacity analysis is given by this. By applying the energy balance, we finally get the formula of temperature profile T minus T infinity equal to Ts minus T infinity equal to exponential e to power Biot into Fourier. This is the exponential temperature drop or temperature drop in cooling body. Thanks for watching.